Yeah, so yeah, first hour was probably a little, not as exciting. I mean, I think it's pretty cool, but like, dealing with a lot of code that's alien is a little tough, I believe. But we got through this, so soon it's gonna be the fun part. Yeah, so some of the people didn't have the leaf, but I hope everyone have the leaf by now. And make sure you need to have this K because we are using the K, the second input. So, if you plugged into the J input, you won't see anything. Make sure you have K, and then your code also has K, and then you should see these leaves. All right, so now that we have a tree, we want to, our goal is to make this interactive with your mouse clicks, right? And to do this, we need to separate the leaves from the trunk. And to do that, we can follow delete SOP. And if you see this L-system too, now that it has L-sys K and L-sys J, and we can separate these J's is what I want. And operation will be delete non-selected. Now we have just these leaves separated. Okay, and the colors are lost, which it's because other ones doesn't have a CD attributes. But at this point, it's really, we don't really need it anymore. So I know we made it, but we cannot delete it. And the strategy is today to instance each. Right now, it's just, we have whatever many points of each circles just copied everywhere. So it's a lot of points now, but it's not so efficient to have it like this. And as well, it doesn't do much. It's just that, there's a static tree. So we want to change all of these leaves to instances. So that's what we are going to do next. And the way we are going to do is, so this was a placeholder, and we are going to replace that with a line. And I want this line to point upwards, so make it 1 in y-axis. Yeah, it's just a line with 2 points. Okay, and so this one will replace. So, now we have kind of sticks at the end of each leaves, and then circle is bye-bye. And so to be able to instance leaves, and then today, we are gonna do just a square card on each leaves to be instanced, and each of them just have a nice picture, texture of the momiji leaves. So that's kind of what I'm gonna do. And to be able to get the right rotation on each instances, we need to give a normal to this line. So again, we are gonna use point SOP, but in a different part. We are going to, so click the keep normal, and you can add normal, and then hit normals here, and change everything back to constant mode, which is this gray square button. I want to have 1 in y-axis. And then, so we define which is the normal is pointing to right now. And that's not just enough to be able to know what direction, there's all sorts of direction it can face, even though it's pointing up this way, right? So we need to add this, if you go to particle page, you need to add up vector. And again, make it constant mode. And for the up vector, we will use z, so 1 in z-axis. So now we added up vector as well as normal, right? And so after this one, we will use transform. and scale y in 0. What happened is I made it viewer active and hit P and turn on the point display. So point 0, there are still 2 points, which is important. But 0 and 1 is in the same spot. And why we have to do this as opposed to just add a point to do that is because this L system can only make primitive groups. And line is a primitive, but a point is not a primitive. So that's why I'm doing this little trick here. And so now if we see our delete, you might want to turn on viewer active as well and hit, make sure your cursor is in this view, hit P, and that'll bring up this display option. So turn on your points, just points is fine. Okay, so now we have nicely, point position that we can instance to. And since each one has 2 points at, each point, and that's unnecessary from here, because, we already got what we want. So now we can do whatever we want. So type in facet. And facet, if you go to consolidate points fast, is good. And what that did, so before there was 1920 points. Now there's 960 points. So it's, everything is half. The duplicated points was now it's 1. So it is more efficient. It should look the same. Okay, so let's put this into a null. And for this instancing, we will make a grid. So it will be the card for the leaf. And for the card, we don't want much division. So we can do 2 and 2 in rows and columns. And right click this output and put down geometry. Okay, so this geometry, go to instance and turn on the instancing. And this null 1 will be our default instance of. So drag and drop to this box here. And then translate X will be P0, Y is P1, Z is P2. The grid is too big, so make your grid smaller. Something like this. I did 0.2. Okay, so you see they are just facing front because we haven't told. This is where you want to tell this rotate to vector. That will be our normal. So pick N0, N1, N2. And then, what did I do? N1, 2. But let me see, I should go back. Oh, I must have done something strange. Rotate to 0, 1, 2. That should be correct. Let me see what's wrong. Actually, I'm gonna look at this example file. Sorry about this. Yeah, that should be correct. I like how this kind of thing happens when you are live and teaching. And 0, 1, 2. Oh. Let me see if they still have a normal. That's good. And great. Doesn't matter. Oh, I have never seen this happen. Instancing. on. I must have done something wrong here. Add normal. Oh. So normal is there. Let me check if the normal is here too. So this icon will turn on the point normal. Ah, for some reason, I don't see the point normal there. I don't see that there either. Okay. It could be. There is one thing I did differently from the example file. So that could be because that it's tube. Ah, okay. Yeah, you should never do differently on live, right? Okay, so these two L-systems were in skeleton, the tube mode, right? And if you go to tube, looks like it will lose the normal, point normal. So that's not gonna work for what we want to do. So in this example file, what I did, I duplicated these two L systems. You can select both of them. And then I kept one for the tube, which is, also champagne. Pointer vector uses X in sample. Thank you. I did notice that. It actually can be either X or Z, as long as it's not the same as your normal. And yeah, I was looking at my example file and I did X. And then later I was also translating, like rotating so that I could make it work. So actually, I think Z would be a little bit cleaner way to do it. So that should be okay. But thank you for pointing out. Yeah. Anyhow, so yeah, for this instancing points, it needs to be skeleton. Okay, so we'll just have this duplicated one for the tube. So this one will be tubes. Yeah, if you could follow this from here, it's important. So, and this chain will be our leaf, the instance for the leaves. And then this chain will be actually rendering the tree trunk. And it's important that, they are the same tree, right? Obviously. So we'll go ahead and delete these two rules. So hit delete. And we will use, same code for that one. So drag and drop that. And that one as well. And I think, for now, that's gonna, both will be following the same rule. But this is like changing like generations and so on. This one, also has parameters. So, if you only change this one, that one won't change. So that will be a problem in the future. So we'll go ahead and take care of that. So for that, like let's right click this one. I'm sorry, right click and parameters. Okay. And then make sure you have this one selected, L-system 2. So we are seeing L-system 4 and L-system 2. Maybe it's nice to name, okay, let's call it L-system main skeleton. Okay, so this one is L-system main tube. Okay, so this one is L-system leaf tube. And that one is L-system leaf skeleton. Okay, so we have tube and the skeleton. And doesn't matter which one drive which one. Wait, main. I have a wrong one selected. Yeah, make sure you have main, tube, mains as skeleton selected. And we want to make sure, you know, they share the same value. So you can just drag and drop these generations like this. Oh, and then do bind. Carl, select my facet node. Yes. Facet node, and then yours is blank. If you mean this part is blank, you might just not have this point. If you hit P, viewer active, hit P, and then you might just have the display off. If you want to see it, you can turn it on. Yeah, you can leave it off, that's fine. And you can always check if you middle click, if you have actually points in there or not. It's always a good thing to check. Okay, so back to the binding. So this one, main tube, main skeleton. Yeah, so random scale, make sure you do the binding instead of referencing. Why binding? It's nice because you can change, you know, either one as opposed to referencing. So it's, in this case, I feel like it's useful. So they are like a twins now. So we do the random seed as well, bind. And these are fine, leave it there, go to value. So do all of them, step size scale. I wish there was one button that can do all of it. And you know, I know you can do like cloning, but I feel like for this one, I kind of want to do this way. All right, so that's good. Next, we'll do right click and then parameters on this one. So leaf tube and then leaf skeleton. Make sure you have that both leaf and the leaf, right? And go to the geometry and do the same thing. So bind all of these parameters. Yeah, go to values. And bind. Okay, almost there. Yeah, it should be pink or like a little purpley, not blue, which is referencing. All right, so that's done. Might as well save it. Yeah, so now what's nice is that tube and this skeleton, you know, they share the same values. So you can do sort of changing the look as you go. All right, so now, you know, I was a little scared that it was broken, but now it's back. You see, it is working. So it is working, but I think this orientation is not right. So this grid, I think you might want to be CX plane. And then, yeah, and then copy this size to the Y parameter and then paste reference, this time references onto the center. Never mind, on the Z. Yeah. And divide it by 2. So that'll kind of snap to that 0. And I think it is nice to also see this trunk, and that's gonna help us to really see if it's in the right place. So we right click this L-system main tube and put down geometry. And let's split this screen here by clicking this two windows on the top left. And on the right side, I will change to geometry viewer. And if you hit H, there is our tree. You can go close to it. Yeah, so that's good. I think that's right. Cool. So I'm gonna make it a little smaller here so that we still have it. So yeah, we got the instance, the leaves now. So yeah, I think we can go ahead and render it then. So let's do that. So put down render top and camera. And we also want light. For you, you can turn on this display. I think it's hard to see if I do that. So I will just kind of right click view and I will put it like small, but like somewhere over here. Well, that's kind of parameter, so let's put it here. Okay. So the camera, I think, can come far back and a little higher. There it is. And then the light, for this case, I'm gonna just do distant light, like sunlight, and then you can rotate. There it is. Where is? Yeah, so that it's kind of coming from, you can change the position, it shouldn't matter, but something like this. Okay. And yeah, now that we have this, let's put textures. So put down a PBR material here. And assign to, we can name this geo to be leaf geo. That's good. And assign these PBR materials to the leaf. Okay. And yeah, now if you could go to the asset folder, I'm sorry, but in the image folder, there is this Momiji texture that I prepared. The way I prepared this one, I found a nice stock image of this Momiji color and kind of photoshopped it so that it crops nicely. And then the rest of these ones, I used a software called B2M, which I think Substance. Yeah, Substance Designer has a bitmap to material, which kind of like automatically creates this normal map, roughness map for you. So yeah, that's kind of the side note. Let's bring everything in. Alpha, roughness, normal. Yeah, just kind of they're probably in the same place. So do that. And then we just assign each one to this material. So go to the map. For the color, okay, we just put color to the base color here. And then I think we can skip height, do a normal map. And then roughness map is good to add the roughness. And then, where is a good place to see it? There it is. So we need to give an alpha channel because they are just cars. And then they are also flipped. We'll fix that in a moment. Get the alpha channel to the alpha map. And after you assign alpha to alpha map, make sure you go to common and then turn on the blending. And then it looks like it worked, but it hasn't because it's weird. You need to turn on this discard pixels based on alpha. Okay, so that does it. Somewhere more. Yes. Yeah, we can give a little bit more generation if your computer seems to be doing fine. To this main tree, let's add to like 7. Let's see. What if I go like 8? That's kind of nice. Yeah, I went on like 8 generations. And yeah, let's fix the flipped orientation, which is this one here. So we can transform this card by which one? It's this way, 180, but now that it's on the other side, so we negate this one. Yeah. Did everyone do that okay? I changed the transform of this card, 180 in Y, and then this grid, I did negative so that it's on this side of the Z-axis. Yeah, this is probably something I did differently in the example file, but it, just make it look right at the end. I think it's fine if you have to flip onto this like a different axis. And then in this where is it? This alpha threshold. I think this should usually help. Like if you are seeing like this like edge a little, it's hard to see on this one, but it's also hard to see on this one. But yeah, this threshold will change. You can see on this one. A little bit just like an edge. If you are seeing like a little like dartiness of the like alpha channel, you can use this value to sort of like shift the edge a little bit. I think the lighting is a little too dark, so go ahead and add an environment light. And then we need a map for this one. So let's go to our image folder. I have this see-through.jpg. This is an 8K texture. And if you're using non-commercial, it will automatically get small. And then it might look not great if it's 1280. So I prepared the blurred one in case this one will look cleaner if you are using non-commercial. But for now, I just go with this 8K one. You can use that one too. And just so you know, you can use the blurred one if you prefer. And assign this texture to your environment map. And for me, it's taking a little time because it's an 8K texture, like I said. It's a high resolution. And yeah, so now you can see, let's bring the camera far back. Now we can see a little better. I'm gonna make the environment 1.5 or something for now. Okay. And right, so you always get this error message that the map is using normal mapping, but the SOP is being used, doesn't have a tangent. So whenever you're using this normal map in the PBR workflow, you need to add a tangent by, so let's move this over here. So you can add what is called attribute create, and then turn on normals and the tangents. Yeah, it needs to, now the warning sign is gone. It needs to have that to be able to calculate this normal map correctly. Okay, so, oh, no worries. Don't worry about ask questions. My leaf geo node isn't displaying the grid. Could I see leaf geo node? This one. I have viewer active. If I make it viewer active and hit W, is this what you are seeing maybe? W goes to wireframe mode, and I might do that quite often because sometimes the lighting is not there. It's really hard to see what is happening, especially with this sort of texture. So if you hit W for the wireframe, you can turn on this wireframe mode. And speaking of, I think it's they're a little too small. So I'm gonna make my grid a little bigger. not too big to the cartoony, but I think, you know, something like this. I do 0.3. Okay. Yeah, Carl, did it work for you? I think it's nothing to do with the parameter. It should be, yeah, view active and W, I think. But let me know if you still have a problem. Oh, the grid leaves aren't instancing. Okay, well, let's see. Let's see. So if you go to this leaf geo and go to instance page, and then make sure you have this instancing on, right? And then this default instance op, make sure you have this null one assigned to this one. Okay. And then translate XYZ, select P0, P1, and P2. And you should see if you do that. And I also have this instance 2 page, the normal. Oh, maybe you are still, did you change this one back to skeleton? This was my fault. This L system, make sure these two L systems that is going to the null one is in skeleton mode, not the tube mode. We changed that area. So yeah, make sure you check that because it's gonna disappear if it's tube. It needs to be skeleton. I'm sorry, yeah, that's my fault. Yeah, but yeah, the reason is, you know, we keep this one as a skeleton, this part, you know, skeleton tree, and this part is the actual tube tree, which we are about to assign some material. Yeah, no worries. You know, I like this study group. I want everyone to, you know, make sure, you know, it's boring if you get stuck at somewhere. So, but yeah, everyone else, thank you for waiting. So let's quickly assign another PBR material to my tree trunk. So assign this. So now it looks nice, you know, we have a material on. Make it like little brown or something, dark. So it's nice to make it desaturated a little bit because that's what nature does, apparently. Yeah, so that's decent. And I may come back to make this texture look a little nicer, but I feel like we might run out of time as usual that I do. And I think I want to get to the important portion. So we can always come back to make this look nicer. But let's think about how. So from here, you know, now that we have this, how do we make, you know, we touch this part and then make the color to change, right? So I want to get on that. Let's save this. And let me drink some water. All right, so to do that, we will be using what is called Magnet SOP. It's a SOP. And let's put this somewhere close to like this end of this null one. So Magnet SOP is interesting what it does. You can use a metaball and, you know, just like the name suggests, it can pull or push points over geometry. So what we are going to do, so this null is the end. So we wanna maybe move it over here. So this part, the facet, that will be go into our first input. And then we are gonna go ahead and put metaball into a transform so that we can move this metaball and put the transform into the second input of the magnet SOP and replace this one like so. Now, I think it might help to visualize the points. So I hit P there. Okay. So now it would be nice to see where our metaballs is too. So I will select this transform and then just turn on this blue button for the display flag. And if we, let's bring this transform like up in Y a little bit and then like X somewhere over here is fine for now. And go to Magnet SOP and then go to attributes. Right now its affect position is on. And if we go to this translate here, do like 1 in Y. Okay. Oh, well, I think my metaball, let's make metaball a little bigger. So now you see, it's like some superpower, you know, this metaball has. It's pushing in, you know, Y position, as you see, right? So that's kind of what Magnet SOP can do. It will be nice to go ahead and make this metaball position match to, you know, wherever you are clicking in your viewer, right? So let's set that up first. So for that, we are gonna go to chop, and then there's a chop called render pick. This one. And render pick wants to know what render top to use. So that would be render 1, it's this one. So we can drag and drop or just type render 1. I do have a render 1 here, but I can't really, this is not meant to select it. So I will close out and let's follow this render 1 with out top. Let's put this over here because that will be, you know, whatever we do in between, this will be our final output. And if we go up in 1 level, so now, since this project is already a container and it has a look page, it has a, you know, out one as a background top. So it's showing what we just put down. And right click your project one like this and then hit view. That will bring this floating window. So if everybody could do that, I will make it a little smaller here so that it's easy to see. If you have like a second window, you can put on your, you know, second monitor. So go inside again. And now if we click this anywhere in your, you know, this project one viewer, you see our render pick is picking up something, right? It is happening. And it's also nice to see, since we want to, you know, move around this metaball position and then do something, right? It's nice to see where the metaball is too, probably. So we are gonna middle click after this transform and put down a geometry to here. So now, you know, we have a nice metaball as well. And this is just for, you know, when you are developing. At the end, we'll probably turn it off, but let's assign a wireframe material here. And I like to make this wireframe more topology wireframe. And the color, whatever, I make it maybe blue. It's like a guide. All right, so now this render pick chop has a lot of options. We want to change this fetch position to into world space. This is very important. Okay, and then let's select chop, and then we select TX, TY, and TZ. And then just in case, let's put this into a null. So we are going to use this position to change our metaball's transform XYZ. So you select this now too, and then go to transform. I'm sorry, make this viewer active, and then reference to this XYZ. Okay, so now your metaball should be following, where your mouse clicks. And your mouse has to select something. If you just select black, there's nothing to select, so it just kind of goes back to 0. So you need to sort of select either the trunk or the leaves. And you can kind of click and then leave it there, it's fine. All right. So one thing I want to do is this metaball position is very crazy, the way it moves. So we can assign here, like include some filter. So that should, make it smooth motion, like an interpolation. So for now, we'll just keep as a default value there. All right, so position is changing, but that's not what I want to do. So go back to our magnet and then go to attributes. So if you see there's a point color, so we turn off the point position, but do the point color. And how it works is, if you go to this deform tab, there's a translate XYZ, right? So X is like R, so red, green, blue. So that's how much you can affect using this translate value. So we just do 1, 1, 1. Just make it white. So we that kind of use as like an intensity, So if where your metaball is at, it becomes white, and we will do the lookup of the color later. It should make sense once we do it. So, and it's important that right before this magnet, between the facet and the magnet, we need to insert operator. And again, it's a point SOP. And then we add color. So it looks like black, but make sure you click that and then do black. Yeah, so that it's actually black, 0, 0, 0 value. And I think alpha is 1 is fine. I think it shouldn't matter, but yeah, so we want to make sure that our starting point is black and we are adding white to it, okay? So let's see if that's really working. If we go to this leaf and turn on this color, now you should have a new, value, which is this CD. So CD is 0, 1, 2. Okay. So it starts black, and since the leaf texture itself is orange, so it kind of goes orange. But what it's doing is like the CD is going 0 to 1 wherever the metaballs are. So this is almost there. But now we actually don't want our leaf texture itself to be orange. We want to make it sort of white, and we want to be able to overwrite the color value using a CD. So I know it looks nice, but let's desaturate. So you can use HSV adjust and then desaturate. And we use this white leaf as a color map. So go to this Momiji color. It's nice to put a null, right? So that we don't have to keep doing this. I'm lazy, but that's why you should do it. So use a null as a color. Okay, so now leaves should go white. Okay. It is kind of cool this way, but I will try to make it, what I want to do is that the leaf is green where it's black and red or like orange where it's white. So we will set that up by look up. Let's make some space here. So bring this that way. Yeah, make it a little organized. Okay, so Magnet SOP has, has the CD, and that's what we want, I think. Although I think we can just do it from here. So this now, at the end, we will convert this into, so I did right click here, and then go to chop and SOP to. And instead of position, we want color. Okay, you can see it's changing, right? Immediately, we'll convert this. And so right click, SOP to output here. And then now we switch to chop to top. Okay. Did everyone get to do that? So basically, we converted this SOP into chop and then chop into top. And you know, they can go back and forth. I just couldn't go straight from SOP to top. That's why I kind of did through that. Okay, so now, you know, it's actually nice to see visually, right? And in fact, so let's check. So this is 32-bit. I think we need to be RGB. Okay, so this chop to, make sure you change the RGB. And in a common page, change pixel format to 16-bit. So I think 16 is good. And then now we can set up a color lookup. So put down a ramp top. And so where it's black, it's gonna be green. And then where it's white will be red. Let's just simply do that. And then do lookup. Oh. Yeah, the ramp goes to the second input of lookup. And then chop to goes to the first input of lookup. And now, okay, so that's working. Okay, good practice to put this into a null. You can name as a color. And this one, if you pay attention to the size, it's 1976 pixels wide by 1 pixel tall. And that should always match to your point number, which is right here. So otherwise, it's not going to work. So go to your leaf. Now we just kind of override this color up by specifying with this top. We're gonna use a new one. And then since this one is not CD, it's called RGB. So delete that and RGB. And B. Okay. So now it is working. Did everyone make it to work? I hope. All right. So now this like chop to this like an intensity map. That's just a black and white map. If we add a little bit of feedback to it, it'll make it, you know, a little, it'll stay longer. So it will look a little nicer. So let's right click and then put down feedback top. And yeah, in the example file, it says over top, but it actually, I changed it to add top. So Yeah, if you are following with the example file, it says over, but it actually is add, okay? And then add this original one, right? And then in between this feedback and add, you want to insert level top. And I will make this, if you go to post page opacity, just a little like 0.995. And then make sure you take this add and then drag onto this feedback top. The feedback takes that the target top. So make sure this is addressed here. And now if we see, this part is slowly going back to green. Okay. And something I thought it's fun is to play with this ramp, gradient. In this example file, I think I did something like, bring like red here, and then maybe have like yellow here. You can play around. Maybe orange there. Basically, this is black, this is white. You are remapping with whatever the color you like. So you can always make it like pink to blue, things like that by just changing this ramp. So I think it's really easy to get artistic there. But yeah, now it's like, it goes orange first, but slowly it goes back to, go through red and it goes back to green. So that's what I did for this example. Okay, so we got the colors. I think now, since we are here, we can use the same technique to add rotation. I think we add the rotation and then we are gonna take a break. So hopefully you are holding up. Okay, so now adding a rotation here, we can just simply take this chop to here and then I do middle click so that we can branch out, add a noise to it. And make your noise, turn off this monochrome so it's in color. And make sure it's also in 16-bit. And let's move the noise. Go ahead and animate this translate. I type in ABS, capital T, dot seconds. Maybe times like 0.3, little bit slower. And then follow this with a null. Maybe put right under the color. So this will be our rotation. Okay, so now go to the leaf instance page. This rotate up, we can assign this rotation. And then that'll be RGB. And I think nothing is happening yet because in this instance 2 page, I think you need to change this to rotate. I think it's one of these. I think its noise needs to be more amplitude because right now it's only probably like -1 to 1 or something. So let's make it like really big. Okay. So I don't know, I think I did like 60. We can think of it, how much degree that you want to affect. But now the noise is, rotating each leaves. And, you can play with sort of a different noise parameter and like make it look like, there's some kind of a wind blowing. Exponent, I think exponent, higher it is, it's more like a crazy storm. And lower, it's a little nice, like a nice sunny day. You can also play with the scale of this transform, I think. Yeah, I mean, if you see it, when the scale is smaller, it's more like, more leaves are doing the same rotation. But, you see, like if it's more randomized, it's like each individual leaves are more sort of more random, in random rotation.